So this is the second topic of regression analysis, measures of variation. So here in this topic we will discuss that how much two variables are interlinked with each other and how strongly related with each other x and y. And we will also discuss that how much change in this dependent variable is because of this independent variable. So we will study these two relationship between x and y through measures of variation, and the formula for measures of variation is SST, SSR and SSE, where SST is further equals to this one. This is y bar is the mean sum of x over n, and y hat, as we have just discussed previously, that if we substitute a naught and b naught into the regression equation, then it becomes y hat. So here this is your y hat, this is your again y bar, and this is again your y hat. So when you substitute, when you calculate all these formulas, you can substitute them back into this equation, you can get total variation or SST. Although it is a lengthy process, but I will give you some direct formulas to calculate it. And this is measures of variation. And here again he is explaining that what is SST, what is SSR, and what is SSE. Here we can see the geometrical interpretation of all these SST, SSE, and SSR. SSE is representing the distance of points from the regression line. SSR is also representing that how much they are close to the mean value. Okay, so we can calculate SST, SSR, and SSE through Excel, but we will do it manually, and I will give you some direct formulas to calculate it. So SSR over SST gives us R square. You will see, and I will give you it as an assignment to do this through the formulas which are given in the PPT. But you can, before calculating coefficient of determination R square, R square tells us that coefficient of determination is the portion of total variation in the dependent variable that is explained by independent variable. As I said, if we have two variables x and y is dependent variable, x is independent variable, we want to see that how much change in y is because of this x independent variable, and that is what we will discuss, that is what we will calculate through coefficient of determination. Before calculating coefficient of determination, there is another topic, or there is another thing which is called correlation. Correlation tells us that how much these two variables are interlinked with each other, or how well does your regression equation truly represents your set of data. And the correlation coefficient R and the coefficient of determination R square will appear in the same manner. The formula for correlation, the formula for correlation, and we denote correlation by R. We denote coefficient of determination by R square, but we denote correlation with R, and it is equals to n times sum of xy. I write coefficient of correlation into the next slide. Maybe I have more space. Let's see. So I write the formula for correlation on this slide. R equals to n times sum of xy minus sum of x times sum of y over whole square n times sum of x square minus sum of x whole square, and then again the same thing with y minus sum of y whole square. So this is the formula for correlation, and correlation tells us that how much they are strongly related with each other. R is always between 1 and -1. So if R is positive, uh, in that case we will say that both x and y are moving in the same direction, either increasing or decreasing. If R is negative, we will say that like x is increasing, y is decreasing, or y is increasing, x is decreasing. In other words, they are moving in a different direction if R is negative. And if R is 0, we will say that there is no relationship between x and y. After calculating R, if you take its square, R square, in that case we will say that whatever results you get, you will say that, let's say if R is let's say 0.5, then R square will become 0.25. In that case we will say that 25% change in y is because of x. So that is what coefficient of determination R squares tells us, which comes through correlation R. I hope it makes sense. And R square is always between 1 and 0. If R is less than 1 and greater than -1, when we take its square, it will ignore the negative value. So that is why it cannot be negative. So we will say it will be between 1 and 0. If R square is 0, we will say that no linear relationship between x and y, same as correlation. So you can calculate R square either by using this formula, which SSR you know from the first slide, SST also you know from the first slide, and you can get R square. I will solve another simple example in an attached solved example with this lecture, and it would be easy for you to understand. And next is standard error of estimate. Standard error of estimate, what it tells us, this is the formula for standard error of estimate. I will see another simple formula to calculate standard error of estimate rather than by using this formula, because it is also time taking. You can see what it tells us. Standard error of estimate tells us that how far or how much variation is in the values of regression coefficient around the line. Here you can see that this is our regression line, and if points are close to the line, standard error of estimate will have small value. So it is better, it is good estimate. It tells us that the data are very much linked, and they have strong relationship between each other, x and y. If points are spreaded around the line, they are not close to the line, in that case standard error of estimate will be larger. Or the magnitude of syx should always be judged relatively to the size of y values in the sample data. That is, if standard error of estimate is 41, is moderately small relative to the house price in the 200k to 400k range. So this is how we interpret standard error of estimate. Now I solve all these three things: correlation, coefficient of determination, and standard error of estimate through a simple example.